The day the world began to drown. 20,000 years ago, you could have walked from London to Paris without getting your feet wet. The English Channel did not exist, not as a body of water. The North Sea was just a river valley. The Doggerbank, now a shallow sandbank and productive fishing ground, was a habitable plain. It stretched hundreds of miles, covered in vegetation and threaded with rivers and streams. It was populated by herds of reindeer, woolly mammoths, and the humans who hunted them. The coastlines of Europe looked nothing like they look today. Britain was not an island, it was a peninsula of a vast continent. It included Denmark, the Netherlands, and much of the bed of the North Sea. Then, approximately 12,000 years ago, something began to happen that would redraw the map of the world. It was more dramatic than any war or empire has ever managed. The ice sheets that covered northern Europe and North America for 80,000 years began to melt. The process was slow at first, almost imperceptible on a human timescale, but it was relentless. Sea levels, which had dropped 120 meters below their current level, began to rise, and Doggerland, that ancient habitable plain, began slowly and then catastrophically to disappear. This is the story of the greatest transformation in the Holocene era. And it is a story that is, in a deeply uncomfortable way, still happening. The world before the flood. To understand how dramatic this change was, you need to understand the world at the peak of the last ice age. The global average temperature was 4 to 7 degrees Celsius colder than it is today. This does not sound like much, but it is the difference between an ice age and a forest. In parts of northern Europe, the average annual temperature was 20 degrees Celsius colder. The summers were short and cool, the winters were long and brutal. The landscape was tundra and steppe, a vast cold grassland, stretching from Spain to Siberia. Ice sheets more than 2 kilometers thick covered Canada, Scandinavia, and much of northern Britain. So much water was locked up in these ice sheets that the oceans were dramatically lower. The coastlines of every continent were different, often radically different, from anything we recognize today. Southeast Asia was not an archipelago of thousands of islands. It was a vast continuous landmass called Sundaland, stretching from Vietnam to Borneo, Java, and Sumatra. It was connected to the Asian mainland by a broad plain. Australia was connected to New Guinea and Tasmania by a broad land bridge called Sahul. The Americas were connected by the Bering Land Bridge, a plain of tundra and steppe 1,000 kilometers wide. It allowed humans and animals to migrate from Asia to North America in waves that populated the Western Hemisphere. Human populations during the last glacial maximum were small and scattered. The cold, the aridity, and the limited food resources of the Ice Age constrained population growth. Estimates suggest that the total human population of the planet was between 1 and 10 million people. That is fewer than the population of modern New York City, spread across the entire land surface of the Earth. Most of these people lived in equatorial regions, in Africa and southern Asia. Northern Europe, covered in ice and tundra, was sparsely populated at best. The first cracks. Around 15,000 years ago, something changed. The Earth's climate began to warm, and it did so in a series of lurching steps. Periods of rapid warming were interspersed with temporary reversals that sent temperatures back down for centuries. The most dramatic reversal of all was a 1,200-year cold snap, called the Younger Dryas. It was named after an alpine flower whose pollen appears in European sediment records at the onset of the cold. The Younger Dryas began 12,900 years ago, and it was catastrophic. Temperatures in the North Atlantic dropped by 10 degrees Celsius within a few decades. That is a rate of change that, in geological terms, is instantaneous. The ice sheets that had been melting re-advanced. The forests that had been returning to northern Europe retreated and the tundra expanded. For 1,200 years, the world was thrust back toward glacial conditions. Then, 11,700 years ago, the Younger Dryas ended as suddenly as it had begun. Temperatures in Greenland rose by 10 degrees Celsius in a decade. The ice sheets began to melt again, and this time they did not stop. It is this moment, the end of the Younger Dryas, that marks the beginning of the Holocene. It is our current geological epoch. It is a moment that archaeologists and climate scientists have spent decades trying to understand. The Younger Dryas boundary hypothesis, first proposed in 2007 by Richard Firestone, suggests that the end of the cold period was triggered by a catastrophic event, possibly a comet or asteroid impact that caused widespread burning across North America. It contributed to the extinction of the megafauna and disrupted oceanic circulation. This hypothesis is controversial, and the evidence is widely disputed. But the fact remains, something happened around 11,700 years ago. The ice sheets melted fast, and the effects on the world's coastlines were devastating. The drowning of Doggerland. There is a region of the North Sea called the Doggerbank, a shallow sandbank, rarely more than 20 meters below the surface. It is a productive fishing ground. Trawler boats drag their nets across this sandbank and bring up more than fish. They bring up mammoth tusks, stone tools, and remains of ancient settlements. These settlements were flooded and destroyed more than 8,000 years ago. Fishermen have been dredging up evidence of a drowned world for centuries. This world was called Doggerland, a rich and habitable landscape. Archaeological surveys of the North Sea floor have revealed river valleys and plains. It is all now submerged beneath water, in places more than 100 meters deep. The sediments contain stone tools, wooden artifacts, and the remains of animals. Mammoth, woolly rhino, horse and reindeer would have sustained human populations. The story of Doggerland's drowning is not a single catastrophic event. It is a process, a long and slow, accelerating rise in sea levels. Some parts of Doggerland were submerged first as the ice sheets melted. The land pressed down by the weight of ice slowly rebounded, creating complex patterns. Other parts remained habitable longer, becoming a kind of archipelago, a string of islands and peninsulas as the surrounding plain was swallowed. The people who lived there watched, over generations, as their landscape disappeared. They saw familiar hills and rivers become islands, then submerged entirely. They moved again and again as the coast came closer. Eventually, the last island went under, and Doggerland was gone. The North Sea became a body of water that separated Britain from the continent. It divided populations that had once been continuous, forcing new patterns of migration and trade. It reshaped the cultural and genetic landscape of Northern Europe, in ways still being studied today. The flood that changed everything. The end of the last ice age was not a single event, but a cascade of events. It was a chain reaction that reshaped the entire planet in ways still being felt today. The melting of the North American ice sheets released enormous quantities of fresh water. This fresh water disrupted the vast system of ocean currents that distributes heat. When this circulation was disrupted, it caused climate changes across the globe. Monsoons strengthened in South Asia, changing the pattern of rainfall in the Fertile Crescent. The Sahara began to dry out as the monsoon rains shifted. New rivers appeared in arid landscapes, old rivers changed their courses, and lakes disappeared. The flooding of the ancient world created the conditions for everything that came after. The agricultural revolution happened in part because climate fluctuations made the region hospitable. Wild grasses like einkorn wheat, emmer wheat, and barley were eventually domesticated. The settlements of Mesopotamia were built on the floodplains created by melting ice. The first cities were built on the foundations of the post-glacial world. The entire trajectory of human civilization was built on the landscape of that world. The parallel we cannot ignore. I want to end with a parallel that I think is both obvious and underappreciated. We are, right now, in the middle of another rapid warming event. The ice sheets that took thousands of years to form are melting in decades. The rate of sea level rise is currently approximately 3.6 millimeters per year. This is faster than at any time in the geological record since the Younger Dryas. Coastal cities like Miami, Jakarta, Shanghai, Mumbai, and London are experiencing flooding. They face saltwater intrusion and the slow drowning of low-lying areas. The people who lived through the end of the last ice age did not cause it. It was a natural cycle, driven by changes in the Earth's orbital parameters. The so-called Milankovitch cycles, named after the Serbian mathematician, Milutin Milankovic, who first calculated them in the early 20th century. But we are causing the current warming. We are the asteroid that is hitting our own planet. And the effects, the flooding, the displacement, the reshaping of coastlines and ecosystems, are eerily similar in their character, if not in their cause. The people of Doggerland did not know the ice was melting, or they could not have known, they could not have stopped it. We can. Whether we will is, of course, a different question, but the fact that we can ask it, that we can understand what is happening, and why, and what the consequences will be, is itself a product of the journey that began when the ice started to melt, and the seas began to rise. Civilization, born from flood, staring down another one. The floods that made Britain an island. The most dramatic single flooding event in European prehistory may have been the one that created the English Channel. The stretch of water that now separates Britain from France, averaging 60 meters in depth. For most of the last ice age, the Channel was a river valley. The Channel River, with a tributary system that drained the rivers of southern England into the Atlantic. The valley floor was habitable. People lived there. The flooding of the Channel was not a single event. It happened in stages as the ice sheets melted and sea levels rose. First, around 10,000 years ago, a large freshwater lake burst through its natural dam, the so-called Storga slide, one of the largest underwater landslides ever recorded, which sent a massive wave crashing across what is now the North Sea floor. Then, gradually, as sea levels continued to rise, the Dover Strait was breached, probably in a catastrophic flood that lasted days or weeks, sending a wall of water across the plain that had connected Britain to France. After that flood, Britain was an island. The Mesolithic people who lived in this landscape, the people whose stone tools have been dredged up by North Sea fishermen for generations, would have experienced these changes, not as a single catastrophe, but as a long grinding series of losses. Their territories shrank, their travel routes changed, the landscape they knew became unrecognizable, and then, eventually, the sea took everything. We do not know what they called their home, we do not have their language, their stories, their songs. We have only the physical traces they left behind. Stone tools on the seabed, bones of the animals they ate, the ghost of a landscape that is now between 50 and 100 meters below the surface of the sea. There is something almost too neat about that. Almost. We are, at this very moment, in the middle of a similar transformation. The ice sheets of Greenland and Antarctica are melting at rates that are accelerating year by year. The thermal expansion of seawater, water expands when it warms, is contributing to a sea level rise. It is currently measured at approximately 3.6 millimeters per year and accelerating. The Intergovernmental Panel on Climate Change has projected that sea levels could rise by as much as 1 meter by 2100. The implications are staggering. 1 meter of sea level rise would inundate large portions of Bangladesh, the Mekong Delta, the Nile Delta. It would create hundreds of millions of climate refugees, and it would reshape coastlines that have been stable for thousands of years. And unlike the people of Doggerland who could not have known what was coming, we can. We have the science, we have the models, we have the historical precedent that tells us exactly what happens when ice sheets melt. We have the story of a world that drowned, preserved in the seabed and in the stone tools that fishermen pull up in their nets. The question is not whether we know, the question is what we will do.